Okay, let's get this one going as well. So this lecture today, this should be your Tuesday lecture. We're going to be talking about absolute value equations and inequalities. This one might be a little bit more difficult than the last lecture, but hopefully it won't be too bad. So let's go ahead and get into it. First of all, absolute value. An absolute value is the distance a number away, or a number is from zero. Wow. An absolute value is the distance away from zero on a number line that a number sits. So it is always going to be a positive number. The absolute value of 3 is 3. The absolute value of negative 3 is 3. The absolute value of 12.6 is 12.6. The absolute value of negative 5,432 is 5,432. It's just the positive form of whatever version. But absolute values in functions can make things a little bit complicated. So let's first look at a basic absolute value function. So the most basic absolute value function is f of x equals the absolute value of x. And this can be rewritten as a piecewise function as follows. F of x equals negative x if x is less than 0. And f of x equals x if x is greater than or equal to 0, right? If any number is less than 0, it's a negative number. The negative of the negative is positive. If any number is greater than or equal to 0, it's a positive number or a 0. So it's already positive. We don't need to flip the symbol. So that's all this is really doing here. The absolute value equation is almost a linear equation, but it hits a minimum value and then the slope becomes a negative. So with every absolute value graph, you're going to see something like this, where you hit some minimum point, and it's not necessarily going to be 0, but you will hit a minimum point at some point, and it's going to go back up. So basically, the slope, if the slope was negative, it becomes positive. If the slope was positive, it'll become negative. So this would be if you had like negative absolute value, right? If the negative's on the outside, then you'd have this. It'd just be flipped. But yeah, we'll look more at that in just a second. So absolute value equations can have 2, 1, or no answers depending on the equation. So let's look at, for an example, the function, the absolute value of 2x plus 1. If we have the equation absolute value of 2x plus 1 equals 3, x can be either 1 or negative 2. If we plug in 1, we get 2 times 1 plus 1, which is 2 plus 1 equals 3. The absolute value of 3 is 3. If we use negative 2, we have 2 times negative 2 plus 1. This is negative 4 plus 1 is negative 3. The absolute value of negative 3 equals 3, so that is also correct. So we get 2 answers. If we have the equation absolute value of 2x plus 1 equals 0, x can only be negative 1/2. There's no other value that's going to give you 0 when you plug in this equation. So there's only one answer. And then if we have the equation absolute value of 2x plus 1 equals negative 3, there are no values of x to satisfy our equation, right? The absolute value of something's always going to be positive, so we can't have a negative answer no matter what we do in here. So that's how you can have 2, 1, or no answers. One of the easiest ways to solve absolute value equations and absolute value inequalities, which we'll talk about in a little bit, is to just use a graphical solution. So if you solve an absolute value equation graphically, all you have to do is graph it, and your calculator should be able to write out absolute values. I think it's like an ABS button instead of the little straight lines, but it kind of depends on what type of calculator you have. It shouldn't be too terribly hard to figure out. And then all you do is graph it, and then you can, in this case, they graphed a line that goes across whatever point they want to find. You don't necessarily have to do that, right? If I wanted to find where x equals 2, I could just go to here, or when y equals 2, I could go to here and here. So I'd have 2 answers there. You'll notice that here's where my one answer is, right at the 0 point, and then anything below that, there's no answer. There's no possible way to get a y value of negative 1 for this function, which is absolute value of x plus 2. So solving absolute value equations symbolically is a little bit tougher. The easiest way to do it is to take out the absolute value brackets and solve for both negative y and y. So as our example that we're going to use, in order to solve 3x minus 3 equals 6, we would just solve 3x minus 3 equals 6, and then 3x minus 3 equals negative 6. So in this case, we would get what, 3, right? We add 3, that'd be 9, divide by 3, we get 3. And to get negative 6, we would just get negative 1. And so these should be our two solutions to this problem. And if we plug those back in, we get 3 times 3 is 9, minus 3 is 6. The absolute value of 6 is 6. If we plug in negative 1, we get negative 3 minus 3. That's negative 6. The absolute value of negative 6 is 6. So both of those are correct. If there's a number outside of the absolute values, the easiest way to do it is just move it over to the other side of the equation and then solve the same way we did before. So if you had had, like, let's say 2x plus 1, whoops, sorry. That's an absolute value line. Minus 3 equals 4. You just add 3 to both sides. And then you have 2x plus 1 equals 7. And then you could solve 2x plus 1 equals 7. And 2x plus 1 equals negative 7. I don't really, that's 3 and negative 4. So there you go. Yeah, so let's look at some practice. We're going to solve these three equations first. So we've got x plus 5 equals 3. Sorry, absolute value of x plus 5 equals 3. So we want to solve x plus 5 equals 3 and x plus 5 equals negative 3. We should get x equals negative 2 and negative 8. So these are the answers we'll get for this one. Subtract 5 from both sides, we'd get negative 2, we'd get negative 8. That one's pretty easy. This time, we have 2x, or the absolute value of 2x minus 3 equals 7. So we're going to add 3 to both sides first. Then we have the absolute value of 2x equals 10. To do this, we just do 2x equals 10, 2x equals negative 10, and that gives us 5, and negative 5 equals x. So that one also shouldn't be too terribly difficult. And then the last one, a little bit more complicated. We got 3x minus 6, the absolute value of 3x minus 6 plus 4 equals 7. We subtract 4, we get absolute value of 3x minus 6 equals 3. So we've got 3x minus 6 equals 3, and 3x minus 6 equals negative 3. We solve this one, we get, what, 3? Add 6, that's 9, divide by 3, that's 3. And for this one, we would get 1. So we add 6 to both sides, that's 3x equals positive 3, x equals 1. So we should get 3 and 1. X equals 1, 3. All right, hopefully that isn't too terribly difficult for you guys. You can always plug these values back into your equation to double check your answers. So if I plug 1 back in, I get 3 minus 6, that's negative 3. Absolute value of that is 3, 3 plus 7, or 3 plus 4 is 7. This one, if I plug in negative 5, I get negative 10 in here. Absolute value of negative 10 is 10. 10 minus 3 is equal to 7. So you can see that you can just plug in whichever one of your answers to double check and make sure that they're correct. All right, next up, let's look at absolute value inequalities. Now, these are a little bit trickier. The solutions to these are like they would in normal linear equations. They're going to give you an interval, but it's either going to be an interval or have no solutions. The very rare example would be if you have less than or equal to 0, then there can only be one answer. So specifically, like if you had the absolute value of 2x is less than or equal to 0, there's only one possible number that satisfies that specific inequality, and it's 0. But otherwise, except in this very rare case, you're always going to have either some kind of interval or no solutions. So here, this is that same example I just showed. The only possible value there is what, 3/2. But let's solve these ones. So much like our previous equations, you're going to do the same thing that you would have before. The difference is that you get an interval instead of a instead of just two answers. And I'll show you how this works right now. So what we'll do is we'll have 3x minus 4 is less than or equal to 8. 3x minus 4. Now in this case, I believe this is going to be the greater than or equal to negative 8. We're using a different symbol here, so it should change out this way. If we solve these, we add 4 to this side, we get 12, so 3x equals 12, x equals 4. So x is less than or equal to 4 for this top one. And then here, we're going to have 3x minus 4, so we add 4 to both sides, we get negative 4. So 3x is greater than or equal to negative 4. X is greater than or equal to negative 4 thirds. And I skipped a couple steps, but I'd add 4, so give me 3x greater than or equal to negative 4, divide both sides by 3, so I get negative 4 thirds. Now, this, you could double check this answer by picking a number between these two values and making sure it works. So if I pick 0 here, right, I get 0 minus 4. Yeah, that's negative 4. The absolute value of negative 4 is 4. 4 is less than or equal to 8. Now, the other way to double check to make sure that you've got your symbols right is to test numbers that don't work. So in this case, I'll pick a number greater than 4. Let's pick 5. So if I have x equals to 5, 3x, so 3 times 5, that's 15, minus 4 is 11, absolute value of 11 is 11, and 11 is less than or equal to 8. Now, the reason we had to shift the symbol here on this one, besides the fact that we made this negative, and you would do that normally in an equation, or in a linear equation, if you flip the sign, you always want to flip the, or if you make the sides negative, then you always want to flip your sign. But in this case, let's say we pick negative 2 as our answer. We'd get negative 2 times 3, that's negative 6. Negative 6 minus 4, that's negative 10. The absolute value of negative 10 is 10, which is not less than or equal to 8. So we have to flip this sign in order to keep them in between. And then what you'll notice is that you've got x is greater than or equal to negative 4 thirds and less than or equal to 4. So this is a interval right here. And then we can write this in interval notation, negative 4 thirds, comma 4 with a closed bracket. And that would be how we solve that first one. So I'll go through it step by step on the second one to try to hopefully make it a little bit less confusing. So the first thing we want to do is we're going to set this equal to 2 and negative 2. So we'll have 2x plus 2 is greater than or equal to 2. And 2x plus 2 is less than or equal to negative 2. Okay. So we'll solve this first one. We're going to get 0, I think. Yeah, so x is greater than or equal to 0. And then for this one, we are solving for negative 2. So that should be negative 2. Let's see. Subtract 2, we get negative 4. Yeah, divide by 2, get x is less than or equal to negative 2. Now, one of the things you're going to notice is that this time you've got less than or equal to a negative number and greater than or equal to 0, which means that, you know, if we plug in 10, it should work. If we plug in negative 10, it should work. And if we do that really quick, we get 10 here. That'd be 20 plus 2, that's 22. Absolute value of 22 is 22. 22 is greater than or equal to 2. If we plug in negative 10, we'd get negative 20 plus 2, that's negative 18. Absolute value of that is positive 18, and that is also greater than or equal to 2. If we test a value that's in between, so like negative 1, if we plug in negative 1 here, we'd have negative 1 times 2, that's negative 2, plus 2 is 0. The absolute value of 0 is 0, which is not greater than or equal to 2. So we know that we probably have our answer right. Now in this case, though, we don't have one single interval. This is a discontinuous function right here. So we would have negative infinity, oh, whoops, not negative 8, or that, negative infinity to negative 2 on our bottom range. This is unincluded, this is included. And then we would also have our 0, which is included, all the way to positive infinity. And you can write the plus in there if you want. And again, you can test any value that fits this range, and it should fit or work when you plug it into this inequality. All right, the last one, x plus 7 less than 6, and x plus 7 greater than negative 6. Okay, we subtract 7 from both sides. In this case, we get x is less than negative 1. And in this case, if we subtract 7, we get x is greater than negative 13. So we can rewrite that if we want to simplify it. X is greater than negative 13 and less than negative 1. And then we just write that out in interval notation. So we go from negative 13, negative 13 to negative 1. And since there's no equal to signs, these are both excluded. So we do normal parentheses. And we can do equals x if you want to. Okay. Hopefully that makes sense. If it doesn't, please bring questions to class. You're going to get a lot of practice on it on your homework, and we've got now 2 days. Both Wednesday and Thursday this week are not going to be any new material or new assignments. It's going to be time for you to get caught up and to ask questions and get help. So please do that. Please make sure you study and are ready for the quiz that is going to be on Friday. I do need everybody to still check in both days. A lot of kids are going to be coming in person on Wednesday. But Thursday, I still need everybody, and Wednesday and Thursday, the people that aren't there, I need to check in on the Zoom call just so I can at least check out for attendance. After that, you'll be free to go if you want to work on your own or study for the quiz that's going to be on Friday. But anyway, that is it for this video.